I am going to be talking about the differentiation of inverse trigonometric ratios like sine inverse, cos inverse, tan inverse, cot inverse, cosec inverse, sec inverse. Now, we're going to begin with the sine inverse of x. The sine inverse of x. The derivative of sine inverse of x with respect to x is equal to 1 divided by the square root of 1 minus x squared. Then for the cosine function, the derivative of the cos inverse of x is equal to the negative of this, negative 1 over the square root of 1 minus x squared. Now what about the tan function? The derivative with respect to x of tan x is equal to 1 over 1 plus x squared. Meanwhile, the derivative d by dx of cot. Remember that cot x is the reciprocal of tan x is equal to negative 1 on 1 plus x squared. The derivative of cot x is negative 1 over 1 plus x squared. Then now let's talk about sec x. Sec x. Derivative of sec x respect to x is equal to 1 over the absolute value of x times the square root of x squared minus 1. And then finally, the derivative with respect to x of cosec x will be negative. It will be negative of this, negative 1 over the absolute value of x then times the square root of x squared minus 1. There is a video on this channel in which I was solving a problem that involved the sine inverse, the derivative of the sine inverse of x and the integration of the result. Greetings to everyone and welcome to another video on my YouTube channel. Today I want to solve this problem in differentiation. The question says differentiate sine inverse of ax and then integrate your results. So given that y is equal to sine inverse of ax, find y prime. And y prime here, y prime represents dy dx. And then integrate your result. So I am finding the derivative of sine inverse of ax. But now I know that the derivative of sine inverse of x is equal to 1 over the square root of 1 minus x squared. So with the notion of this, I'm going to use the chain rule to differentiate the sine inverse of ax. So I'm going to do it like this. I'm going to apply chain rule and I'll have that sine inverse of ax will be equal to, it is going to be equal to the derivative of the sine inverse function times the derivative of ax. So it is going to be 1 over the square root of 1 minus ax, all that is squared, then times the derivative of ax in respect to x. Good. So with this now, I know that when I differentiate ax in respect to x, I have a. So this is going to be equal to a times this is going to be a on the square root of 1 minus ax all that square. So this is the value for y prime. Y prime is y dx. But now the question says, and then integrate your result. So after having the derivative, let us now integrate the result. It means we are going to have, it means we are going to have the integral of a divided by the square root of 1 minus ax all squared dx. So how am I going to do this? To start with, in this integration, I'm going to send the constant a out of the integration. I'm going to send it behind, in front of the integration sign. So I'll have it as a times the integral of 1 over the square root of 1 minus the x other squared, then dx. At this point, I'm going to use substitution to be able to complete the solution. I'm going to use the substitution u equal to ax. So if I let u to be equal to ax, I will have that du dx will be equal to a. And then to continue, I'll have that dx will be equal to du over a from here. So my integration becomes a times the integral of 1 divided by the square root of 1 minus ax becomes u squared, because I have let u to be ax. But now, instead of dx, I am now integrating du, and then dx is equal to, I'm replacing dx with du over a. So I will also have a here. So here I have dx, and then since I'm integrating du here, and dx is the same as du over a, so I'm replacing dx with du over a, du over a. And the next thing I will do is to send out the a as well. So I'm going to have a over a over a times the integral of 1 over the square root of 1 minus u squared du. And from what I said at the beginning of this video, I said the derivative of the sine inverse of x is equal to 1 over the square root of 1 minus x squared. Just compare with this one, we now notice that this is 1 minus u squared, which is, so if you integrate, because from here it means if you integrate this one, you have sine inverse of x. So it means if you integrate this, you have sine inverse of u. And a on a, that is going to cancel off. And I'm going to have the sine inverse of u a plus a certain constant. But now, u was equal to ax. I'm going to replace it there and have sine inverse of ax n plus the constant of integration. Alright, thank you for watching and see you in the next video.